Your designated note takers. Robin, I. Robin, could you please help take notes on the Zelista through the Zelista ones? I don't want private notes. I've got to give them back to.
Can I get them?
No,
get the notes.
Put it on the Etherpad.
Okay, I'll put them on the Etherpad. I may not be able to look at it.
I'm not
I'm going to take directly into the graduate. I don't know.
Should we wait for Daniel or should we start? And Mike is missing as well.
Who else?
Mike.
Sorry. I think we can start with the introduction.
Yeah. Do you want to say something first? Or should
Yeah. So this morning we have 3 back-to-back sessions around EAS. The first one is around what happened at Kernel Summit. So a bunch of engineers from ARM, Qualcomm, Linaro were at Kernel Summit in the EAS track. And so they're going to talk to us about what happened there, what are the agreements we made with the maintainers. Then we'll have a quick recap around the tools we are currently developing. Should be a 5-minute recap really, because we already had a session about this on Tuesday. The second session, the one after the break, will be about Qualcomm talking about their EAS implementation. And the final session of the morning will be about Morten walking us through how to create energy models that will work with EAS, and then finally a last 15-minute wrap-up on what are the next steps. So with that, I'll hand over to Morten to sort of lead a panel around what happened at Kernel Summit.
All right, thank you. I'm Morten Rasmussen. I have, well, as Amit just said, this session is about what basically happened at the workshop at Kernel Summit. Kernel Summit was 3 weeks ago in Chicago. We were lucky to have a workshop accepted, a full-day thing, dedicated to EnergyOS scheduling. The goal of the workshop was really to coordinate all the efforts that are in the community right now around improving EnergyOS in the scheduler and all the power management frameworks in the kernel. We had good attendance to the workshop. We had basically pretty much everyone we wanted there in the same room, which is a bit unique. It doesn't happen very often. We had the scheduler maintainer there. We had people from Google, and as Amit said, we had ARM, Linaro, Qualcomm, and representatives from IBM as well. So it was really useful to have everybody in the same place. Some of you might already have seen some of the summaries that's been posted on LWN. There is a short summary by John Holbert. I wrote a slightly longer summary based on notes from Mike and others, which can be found there as well. I have the 2 links in the slides if you want to read those. I've put the agenda here. That this is basically what was discussed in the day. We had discussions around benchmarking and testing. That was mainly led by Linaro folks. We had discussions about some of the internals of the scheduler load tracking. We need to change a few things there to help our work on EAS. We had discussions about scheduler CPU freq integration. Integration of CPU idle. I did a talk about our whole energy model idea. And then finally there was a bit of discussion around how to do power management in virtualized environments. So I would actually ask some of the Linaro folks to talk about the first session about benchmarking and testing, because that was mainly led by Daniel and Mike.
Sure. Yeah, so a couple of things happened while we were at the Linux kernel summit asking about the tools that people were using for benchmarking and testing. We had a bit of a poll of the audience to see what type of tools they were using internally. We can even do the same today if that's useful. And we also started out by kind of introducing or re-announcing 2 tools that Linaro has been working on recently. So some of you may have seen email announcement for Idlestat and for rtapp. So rtapp is a workload generator that came out of the rtapp tool, which was a already existing tool in the community. And then Vincent and some others have made quite a bit of changes to it so that it does the type of workload generation that is helpful for us to do kind of standardized testing. And one of the benefits of this is you can write a workload in a JSON file format and share it with other people, and they can run that exact same workload on their machine using the tool. And then Daniel, maybe you can give a description of Idlestat.
Yes, Idlestat is a tool to based on the traces from the ftrace framework of the kernel. So it takes all the traces saying we are entering this idle state and we are exiting this idle state. As we have the timestamps, we can measure the duration of the idle states, and it does the same for the frequency changes. And on top of that, it does a calculation thanks to the topology. So we retrieve the topology, and with the topology, it does a computation of the intersection of the idle tasks for each CPU belonging to the same cluster. So it gives also information about the cluster. There were a great interest from Intel on this tool, at least for the guy who were in the Kernel Summit, and they would like to add to this tool some plugins like be able to use the hardware specific register on Intel to get real consumption. And they suggested also try to find a way to correlate this information with the scheduler decision, and especially what is in /proc task proc pid stat. And well, that's all mostly.
So when we were polling the audience about the type of tools they used, I would say that things kind of fell into 2 buckets. There's the full-blown benchmarks that are used by the community, used by the press, Geekbench, Quadrant, things like that. Folks are never going to stop using those because that's the bar that everyone's held to. But additionally, there's a lot of homegrown stuff, especially when it comes not only to benchmarking, but also for power testing and regression testing, and also workload generation. And so I felt that in the room at the Linux Kernel Summit, there was for the homegrown tools, people were pretty interested in trying out the 2 tools we've just mentioned and seeing if those work, and there's some level of standardization that can come from that. Did you want to do the same thing here, ask the audience about what tools they're using, or did you want to just kind of fly through the summary? So. Yeah, okay, great. So maybe we can do the exact same thing we did at the Kernel Summit. So for maybe workload generation tools, or for some kind of power consumption estimate tools, what are folks using today? What type of tooling around energy-aware scheduling, or just or power management in general is everyone in the room using? We can pass the mic around.
Someone must be using something, right?
Yeah.
Otherwise,
No one's measuring power.
No?
I guess maybe we weren't playing that into the automation suite. Some people have that. It's not. So we have workload automation suites for generating workloads on Android specifically. ARM has, sorry, when I say we, yeah. If anybody's interested, come talk to us. But, yeah. And we do a lot of scripting, which is equivalent to what Idlestat does, so that Idlestat will get rid of our scripting effectively, I expect.
So the plan is to switch over to Idlestat once that becomes robust enough?
Yep.
Okay, cool.
The scripts written by individuals for themselves, it wasn't really a tool as such.
So what do you guys use to measure power?
That's a good question. Let's come back to that in just a second. So for measuring power at Lenaro, since we have home laboratories, there are some of us that do real power measurements at the battery or on some of the rails. I do some of that myself, and soon I'll be starting up a automated power regression testing thing, which is similar to like the boot testing that you see, where folks that have board farms at home, they'll do boot tests and report on failures. So I'm still soliciting feedback if anyone wants to guide me on how to report this. The goal was to take a known tag, typically like a full Linux release tag, get a baseline energy measurement across some workloads that were probably generated from rtapp, and then without publishing actual raw power numbers, check for regressions with every RC release that's coming out after that, and as a percentage of more or less energy consumed. And so no one's really disliked that approach so far, but if you have some...
That's exactly.
Okay, yeah, so if you want to know, if your company would like your board to be a part of this automated power regression testing, then I'm always happy to take hardware. So.
The other thing that's useful is to have some idea of what's an acceptable level of error. So when you're reporting the deltas in percentages, you'd have some kind of confidence associated. So for some use cases, 5% might be significant. For other use cases, 5% might be in the noise. So some kind of notion of that, so that then you can literally eyeball it and go, something's broken there, or everything's okay. That's kind of what you're looking for.
We sort of did the same thing, but we needed some trends first, so a couple of iterations, and then you start building a confidence level on that basis, right? Then you watch for deviations. But if you have this infrastructure in place that you guys are talking about, it's spot on.
I guess one thing, quick question, just what kind of tools? Because we use two main sets of tools, I guess, and we've got it all integrated into the workload automation suite thing as well, so we can generate the workload and measure it. But on some platforms, we have built-in power measurements, TC2 and Juno being good examples. Even actually, the Odroid XU3, that's got built-in power measurement, though it's slightly more invasive. And then the other thing that we use is NIDAX. Kind of curious what you're using for your power measurement. Are you using a hardware tool like that, or?
Thanks. Yeah, so I've used NIDAX a lot before, but right now I don't have one in my home setup. So I would say there's about 3 different ways that I'm measuring real power. So one is the onboard power measurement Chromebook. 2 also has that, which is one of the platforms, like TC2 does. And then it's very easy to set up measurement at the battery or at the DC input for me. So that's like the very first step that I do if there's not onboard power measurement. I just start looking at battery level. It's not that interesting. And then I do have methods to instrument up individual rails if I either have probe points or I can figure out, like an inductor on the board or something. And so for that, an NIDAC would work, but there's Also, some new hardware I have coming in from Saleh, the company that makes Logic Analyzer. They're kind of getting into the scope business as well. So that will probably be waiting outside my door when I get home from this trip, and I'll be happy to report on whether or not that is a good tool here in the next couple of weeks.
Is it more cost effective?
Yeah, it's cheaper. So, yeah, and it's got great Linux support. It's got good cross-platform support. Yeah, Mac, Windows, Linux. It's quite nice.
So we use NIDAX when we're doing the per rail measurement. We like the resolution and the sampling times of the NIDAX. We don't like the lack of Linux support or the poor Linux support. We'd like to work with that vendor to fix that, and we have communication with them. But if there's another tool, we're very interested. Internally, we've integrated the NIDAX stuff with WA2, but there's no reason we can't integrate other tools.
Cool.
And the other thing, very briefly on the energy measurement, because it's kind of a hobby of mine. The way that Juno and TC2 measure energy is both, you can sample using hardware mod, or you can sample an accumulated energy, which is extremely non-invasive, and it removes an enormous amount of noise from the measurement. So there's a microcontroller accumulating energy over time.
Yeah, so if you could share some information on how to do the accumulated stuff, that'd be really helpful.
Very happy to.
So, yeah. Great. Right. Anybody else want to share the secrets of their workload testing or power testing secrets?
I think that right now most of the people are doing some real parameters. The only safe and precise way to do that. And having some tools, full software tools, is something that a lot of people are waiting. At least to have a first. It's a trend. Maybe not the final result, but the trend.
The two are complementary.
Yeah.
Nothing beats measuring power outright with instrumentation. But the good thing about Idlestat is the way it's shaping up. It can be coupled with an energy model that's giving you custom information for peak states and breakups. And then you sort of have a not very crude.
Is there a mic over there?
Hello. Yeah. I was just saying that ultimately using instrumentation for power measurement is where everyone wants to be, right? But there are logistical issues doing that. But one of the design intents behind Idlestat was to actually use residency analysis coupled with costing information via some sensible energy model to give you a not too crude and very workable sort of indication of the power cost of running workloads, right?
But you can't validate the energy model.
That's true. But you can also come up with a scoring system that's not entirely, scaled one, right?
I was pushing this.
Yeah, absolutely. So I think that's a step in the right direction, basically.
And the engineers have already talked about it this week, and so the energy model bits should get merged soon enough.
Cool, awesome.
Dietmar and Larry sat down this week, so I think it's just a matter of spending some time cleaning up the patches and getting it merged.
Can we send something out to the viewer?
Larry, did you want to elaborate on the energy model stuff?
Yeah. Well, the idea here is you have some algorithms that I concede were pretty much developed by Dietmar that go and calculate based on what's essentially we use a file that says if you're in this P state or in this C state, this is how much energy you've been using. If you wake up, this is how much energy you've been using. It goes through all the F-trace events. And Idlestat already did go through the F-trace events and count the P states and C states and the IRQ wake-ups. But what it does is it applies this formula, makes a few assumptions that we're going to try and relax so we don't need these assumptions. That's some of the work that we're bringing in from Patrick from ARM. And just calculates this number. The idea is that this number really doesn't mean anything except that it's relative between, I run this kernel, I get, 1 million. I run this kernel and I get 1.1 million, then I probably have a worse energy than I used to have. You could think of it just as a benchmark number for energy, essentially. So the idea is just to take the results of a run and a workload and make a good and hopefully improving as time goes by estimate is if you would actually plug into an energy measuring box. It's a lot easier to run Idlestat than have to hook it up and play with it, and there's probably some hardware that you couldn't even do that with.
I think that's a pretty good summary of the tool stuff.
I suppose from a maintainer perspective, there would have been a strong pull to get these tools out and in the hands of the maintainer sooner rather than later, right? So I think that's where we need to focus our energies on, no pun intended.
Yeah, I think one of the main feedback points we got from Peter was that we should really get this suite of benchmarks done, and we should agree on the benchmarks in there in the community and start sharing them and start using them. I think it sounded like at least some of the others, like Intel folks, would go back and actually have a look at it. We haven't heard anything yet, but
Yeah, so
okay.
So we haven't heard back from the Intel folks. So, so one of the key things they're interested in is actually exposing some of the scheduling statistics rather than the B state and C state and wake up statistics that we are currently considering in Idlestat. And their reason for bringing that up is they want to be able to see, track things like task migrations and cache effects and all of that. My argument to that is that that's not the primary reason why we designed Idlestat. We can definitely consider adding those features in, but I think for now, Idlestat was meant to support EAS, and as such, it should be able to help track the power behavior of the influence of the scheduler on power management. And so I want to focus on that first, and then consider adding these other bits around scheduler statistics later.
Sure. I think some of the scheduler statistics are quite difficult to relate to power consumption. It would be nice to have them there, of course.
Yeah, but I mean, it would be hard to say to draw conclusions from them.
Yeah, I mean, the number of task migrations doesn't really tell you if you use more or less energy.
Exactly. I mean, if people can come up with how to correlate that to
sure.
energy, yes. But until then, we want to just focus on getting what we have correct.
Okay.
Did Intel say anything about a system when they use the Intel P-state driver where you don't have the available P-states anymore? Then probably using the Idlestat tool is not really helpful, because the whole tool relies on that you know which P-states are available in the system, and running Intel P-state driver doesn't give you the information anymore.
You mean running Idlestat with the P-state driver? Yeah. We actually fixed that one, right? Yeah. So
if you run an Intel system with an Intel P-state driver, where do you get the available P-states from? I mean, they are not exposed anymore, right? So you get the current frequency of the system or for each individual CPU.
Rely on the traces. So it's the traces giving us the information about what P-states we went. So we don't have the list of the available P-states.
So you only have the current frequency.
For the P-state we don't enter, it's just 0.
Okay.
And at a certain point, if Intel is interested in this, they'll probably come up with a fix. I mean, improve that prediction or see if it actually works correctly for them. Because we don't know enough about what's happening in the back end in their hardware.
Yeah, I have the feeling that they want to get even like one step further, so let the hardware control the P-states itself, and so there is less and less possibility for software to control stuff, and this might actually harm us when we base tools on this kind of information, which right now works on ARM perfectly, but in the long run it might not work anymore.
So what would you suggest?
I don't know, but we shouldn't look for those kind of developments, and I mean, if we don't convince them to be part of it, we might have a hard time at the end getting this energy-aware idea into mainline, right?
So I'm hoping to talk to, I'm hoping Rafael or some of the others from Intel are going to LPC next month. So I'm hoping to have a chance to talk to them at Flowers.
So our impression is that firstly, there are participants in the discussion from Intel. We perceive an opinion from the maintainer side that you know, this is an optional feature at this point in time, right? So if your system supports this functionality where you are getting, to some extent, verbose information about, you know, what frequencies you're running at, etc., then you have this option. You have EAS, you can use it, and the tooling will therefore reflect what the system is capable of. But if you don't, then that's not a blocker. Right? It'd be great if there is a. It would be awesome if there was a solution that could cater to like systems where the firmware is in control and is not allowing the operating system to dictate its destiny. But you know, we have to choose one or the other. Right?
A lot of the reasons those features are developed is so that you can cater with legacy OSs that don't have the advanced pattern management in them. You know, so if you wanted to put a very old kernel there, but you want to exploit the power management features of your CPU, you actually have to end up putting the smarts somewhere else.
I was just going to add that the feedback in terms for the tooling, the feedback in terms of what frequency you're getting should always be in, right, on the Intel systems. It's just a matter of who's in control, right? The control piece may or may not be broken depending on how it's divided, but the feedback, so that you can understand and you know, build a model of what the consumption is, should always be there.
All right, we should probably move on to the next one. So the next topic was basically to try to get things sorted out with all the load tracking bits in the scheduler. Well, this is quite technical. There is this load tracking stuff that was added by Paul Turner from Google a couple of years ago. We rely heavily on that for all the EAS work because it gives a sort of more accurate estimate of the load of each individual task based on its execution history. But we need to tweak it a bit to make it better for our purpose. Right now it's scaled by priority, for example, which means that the load is not really the CPU utilization, it's the CPU utilization of a task scaled by some random number. We're going to change that. We need an accurate measure of the utilization of each task to do better prediction of what would the load of the CPU be. So in this discussion I brought this up and we discussed with Paul Turner, the original author, he was there, and Peter, how we could go about adding a better utilization metric. To put it very short, I think we all agreed that we need a utilization metric, and I think the maintainer was happy to add that. Without going into too many technical details, there was already some stuff in Paul's original proposal that never made it in. We'll take some of it back in. I know that Masson is already using that in one of his patch sets that's already been posted. And we're going to use it for scale invariance, which was also discussed. Scale invariance means that we actually factor in CPU frequency changes and microarchitectural differences like on big little in the load tracking, which is not there today. So if you have a task which runs 50% of the time at a certain frequency, then it will appear as having 50% utilization, but if you change the frequency, you will also change the sort of utilization tract. So you can't really compare utilization between CPUs or even between different P states on the same CPU. But we're going to fix that. We already have a patch set that does it. We actually did the first prototype of this a couple of years ago, I think. But now finally we agreed that it is needed, and I think the maintainer and Paul Turner, they're both happy to go ahead and extend the existing load tracking to do what we need to do. There was also some discussion about getting the terminology right, because we all go around back in our offices and discuss the various aspects of this, but a lot of the terms we use in the discussions on the list are not really well defined, so quite often we get confused in the discussion. So it was also agreed that we should actually do a proper documentation patch to try to define a lot of the concepts that we use, or terms and concepts from the load tracking, because yeah, there's just too much confusion when we discuss things online. So I think we're going to do that sometime soon, do a proper write of what's actually in the scheduler today, because the scheduler documentation in the kernel is quite simple. It doesn't really describe all the load tracking very well. So we're going to fix that. And I think that discussion sort of morphed into the discussion about how we do with the CPU freq and the scheduler, because we need to do the scale invariance. We need information about frequencies inside the scheduler, so we can compensate the load in the load tracking for frequency changes. But at the same time, maybe it makes sense to establish a link going back. So if we know the exact utilization of the CPU in the scheduler, why not feed it back to the CPU freq framework and actually pick the right frequency? The way it works right now is that the CPU freq is completely decoupled from the scheduler, which is not really ideal. And Mike was well, he's working on that, so we better let him talk about it.
Yeah, so this actually goes back to Ingo's famous, line in the sand email where he said outright that CPU freq should be integrated into the scheduler. So having the scheduler more or less select the frequency that the CPU should run at based on the workload. And so as Morten was saying, there's already some feedback for the scale invariant task load stuff where you need to know this frequency of the CPU, you know when it changes and what it's going to change to, so that you can compensate for scaling the task load. Why not just do it the other way? Why not also update the CPU frequency based on the given utilization? So maybe I can just transition into did you want to go to the next section? Or did you want to keep going on about the task CPU utilization tracking?
No, please.
It's worth clarifying that it's been a few weeks since this happened, so there already are actions and code emerging out of this, right? So Morten's going to be posting the scale invariant stuff that we spoke of this week itself. And in terms of the terminology clarification stuff, we would like to have a stab at posting out a patch that tries to consolidate all of the various bits of terminology floating around and see whether that helps. And I don't want to prefetch on your behalf, but you can give the update on the sched CPU freq code submission likelihood.
Question about the documentation patch, because some of the meaning of the terms will change, right, a little bit. So is it going to be of the nature where it's like this is what it means today and this is what it's going to mean in the future? Yeah. That's good. That's good. So. As far as the RFC for the CPU freq and scheduler integration, it's a very simple approach just to give feedback, and I'm hoping to post it very quickly after the scale invariant stuff goes out, so likely next week. So I'll just transition to the next portion. So there was a discussion about merging the scheduler and CPU freq together at the MGWare workshop. And there were a couple of arguments that kind of went off into the weeds. I'll spare you guys all of that and skip to more or less the results. So there was agreement that the RFC would be built on the scale invariant stuff, as I've just said like 5 times. And an interesting point was that for the most part we mostly had consensus around reusing the CPU freq governor interface for this shim layer between the scheduler and the driver that actually will change the frequency. And so this is it's interesting because it's good. It helps us reuse the CPU freq machine drivers. I mean, anyone that's ever written a driver to actually scale the frequency, why redo that work? It's great to reuse it. And then also the downside is that it is using a governor interface, and somehow CPU freq governors have fallen out of style to a degree. But that's a minor detail. If you have comments, we can tackle that on the list when it's posted. And then also almost anything that's written as the CPU-free governor layer, it really is a shim, and that is expected to disappear with the advent of the energy model later on, and we'll just go from there. And so that was everyone mostly agreed with that. A minor bit of contention. We'll handle that on the list. I'm not too worried about it. Also, for now, we're not at all concerned about solving the data table problem. Whether you want to import your P states from ACPI or DT or something, that's out of scope for what we're trying to do right now, because that will just massively distract you. And actually, those are most of the actions that came directly out of the meeting, with just a few high-level design details. So if you're interested in being CC'd on that, let me know, and I can do that, because the more eyeballs and comments we have on this stuff, the better it'll turn out. So, was there? I mean, I don't know if there was any other recap really to discuss there. I mean, a lot of it was hemming and hawing and sort of debating. So.
Yeah, I think that pretty much covers it. I mean, we agreed to move forward with the scheduler CPU freq integration, right? And particularly the maintainer and the Google folks were really interested in actually getting rid of CPU freq and actually just drive it directly from the scheduler, because the scheduler already knows, get rid of all the sampling overhead of the governors and all that.
Right, yeah, maybe it's worth just discussing the actual technique a little bit. I mean, we're getting rid of sampling windows and maintaining a parallel set of statistics. So if you're familiar with on-demand governor, or really almost any of the governors, besides user space and power save and performance, you typically maintain your own set of statistics based on some tunable sampling rate, and those are parallel statistics compared to what the scheduler already understands about its own usage and utilization. So we're talking about getting rid of that, and when the scheduler updates statistics and it knows what the utilization of a CPU is at a given time, at that point make a decision on whether or not the CPU frequency needs to change. So while it's true we're reusing the governor interface, this is very event-driven. This is, some event has happened, utilization has changed, let's make a smart decision, as opposed to we're going to have some periodic sampling rate at which we, maintain our own set of statistics and make a decision. And it's worth pointing out that decisions that are made today, with the exception of some work that has been done in some downstream kernels, it's invariably decoupled from like a load balance operation. So you're scaling CPU frequency and you're changing task placement, and the twain shall never meet. And so it's just also a goal of the overall energy model and all the EAS efforts to get these united, so that you're not working against yourself, scaling making a CPU fast only to migrate a big task off of it onto some slow CPU. Like whoops. So that's where we're going, taking it in pieces.
So for the CPU freq, as far as the interfaces are concerned, there's like two ways of requesting CPU frequency. There's that target method, which essentially relies on a discrete set of P states, and then the governor sort of picks one index in that table. And the other is the set policy method, which is sort of giving more control to the driver and then handling its own thing. So I guess then the question is what's the preference here for this integration effort? Use the discrete set of table, this discrete set of states, or the other method?
So we don't know yet what the preference will be. So I can tell you how it works today, which is that there is a CPU-free governor that is very similar to the way on-demand works. Now it's event-driven and it gets called from the scheduler context, but it looks at CPU utilization, and if you're over 80% CPU utilization on that CPU, then it will just pick the fastest P state. So either of those methods work fine for that, right? You don't have to know what your P state table is, and then if you're between 20 and 80%, then it makes no change, and if you're less than 20%, then it will try to walk down until you hit that sweet spot between 20 and 80% utilization. So as far as the actual machine driver method that you use, there's not a strong stance on how you do it. I mean the governor policy that we have today should be compatible with both of those methods. So
okay, that's good to know. Then follow-up question to that would be, so like there used to be a method to actually hook into some sort of feedback counters in the past governors to gauge what was the past performance, or rather what was the past CPU frequency in your last interval. And then they took that out because they found some issues with that. So now it's essentially just coming entirely from the scheduler, and they were kind of measuring what the load was and how much time the CPU was actually idle, etc. So in this new framework, are we going back to, or is there any plan to add hooks to actually read feedback counters?
I can let some of the other guys comment on whether or not that's going to be added back into the scheduler. I really don't know. But what I could say is that you can imagine all the statistics that you might have used in the past in the CPU freq governor. You can imagine those as being significantly more accurate, as accurate as the scheduler's own statistics, because they will be the scheduler's own statistics. So I don't know if that helps to answer your question or not. I don't know about that particular feature that you're referring to. But
it's not necessary anyway if you have scaling variant auto tracking, because that's the part where you need the frequency.
is that what that feature was used for? Was to basically account for change in CPU frequency to massage the numbers? Okay. Well then I guess we'll have that from the scaling variance patches.
We don't have that much time left. Okay, would you talk quickly about the ISO integration?
Yes, so the improving the Idlestat selection is can be rephrased on saying how can we predict the next event more accurately. So there were a discussion about the proposed solution, which is using the paradigm that we don't care about the different noises we have interrupting a CPU and waking up a CPU, but just relying on what we can consider as predictable events like the timer or the IOs, which are occurring in an acceptable amount of time. And then thanks to that, we can move the prediction from inside the CPU framework into the scheduler directly, and then tell the CPU framework we expect to sleep this amount of time, and we have these latency requirements. So the CPU framework would just choose the right state for us, and we will use this state to sleep. So by having this information in the scheduler, we can do better decision about task placement, knowing when the CPU is supposed to wake up. So knowing if it's worth to wake up a CPU in order to balance a task on this CPU, and well, all this kind of decision. But it's a two-step integration. So first step is to try to make more accurate the prediction. The prediction next event, for the next event, move this inside the scheduler, and then from the scheduler, as we have all the information, we can do the right decision. So right now it's it's a lot of code cleanup in CPU framework in order to move this around without breaking what we have today. Pitre did send a patch set by moving the code around for the menu governor, so integrating directly the menu governor inside the scheduler, but we disagree. I think we disagree with this approach, because that does not mean we are really integrating the CPU framework inside the scheduler. So, well, there is some work ongoing in this area.
Okay, thanks. So, well, we had some discussion around the whole energy model thing as well. I won't go into too much detail here. We have a session, the one after the next one, where I'll talk more about energy models. But the basic idea we presented there was Instead of trying to come up with a bunch of tunables that the scheduler maintainers hate to tune scheduler behavior, why don't we just put in a simplistic description, an energy model of the platform we're running on into the kernel, such that we can actually compute or estimate the impact of whatever scheduling decisions we make. It's very simple. It's basically just a bunch of tables with the power and energy data for P and C states. And based on the utilization that we now have in the scheduler, we can actually figure out, if we move a task from one CPU to another, we can figure out what will be the new P state of the two CPUs, and try to figure out, does this move actually save power or not? The nice thing about the energy model is that all the data you have in there are actually related to the physical sock that you're running on, so it's actually parameters that you can measure. Whereas if we come up with a bunch of heuristics, we might end up with 20 or 50 tunables which don't really have any meaning, and you need to be very well aware of all the scheduler internals to actually tune it properly. We asked the maintainers pretty directly whether or not they thought this was a stupid idea, and it seems that they're happy with going forward with this approach. Of course, it's still largely unproven. We're still working on it. We have a mock-up implementation that doesn't do everything we want yet, but it seems that they're happy with the approach. So going forward, we just need to execute on this idea and basically start delivering patches. And I think because they now see how all these bits, the CPU freq integration, CPU idle integration, improvement of load tracking, and by adding this energy model, so we can actually make some informed decisions make some informed scheduling decisions, I think they're happy to start taking patches that will slowly add up to becoming the final solution.
Do we have any idea where we expect all of this data to come from?
So that was one thing that was discussed as well. Right now we don't really care too much, but our idea is that, yeah, it could come from device tree, it could come from ACPI, it could come from a driver. I mean, if your platform doesn't support any way of providing it through ACPI, device tree, or some third mechanism, the maintainers were happy to just have a driver that would just have a full table in there. There was actually a quite heated discussion around providing those tables through ACPI.
That's why I said it's out of scope.
Yeah. So yeah, we don't care too much. I mean, the prototype we have right now, it's just hard-coded into the Arch ARM code, which is not how it should be, but this is where we started. I mean, it's more plumbing to get that right. I think we need to prove some benefits in terms of scheduling before we start worrying about how to actually get the data in there.
I would guess that it's going to be like a proper driver that has the data in it, and then people will use that to figure out the other bindings in the future, maybe, yeah. Right? So 'cause that's easier for us to write, just some C code. So, yeah.
Now the agenda is gone. The last topic was power management and virtualized environment. That was raised by Pitre from IBM. They had some interest in communicating power management decisions from the guest into the host, and there was quite strong pushback on that idea. We had Mark from the ARM kernel team there and said, no, please don't do that. So if, in general, it's a nightmare doing power management in a virtualized environment. The IBM people argued that, yeah, if you've got a very strict partition, so if you sort of dedicate a number of CPUs to a specific guest, then it could make sense, but otherwise, I think it's going to be difficult. And the discussion wasn't really that long. I think that was pretty much it. It was a whole day thing, so we came through a lot of things, but I think in general it was really a useful workshop.
Do you want to quickly go over the next step as far as the patches and expectations from maintainers are concerned?
yeah, I mean, we still need to deliver some tools. That was requested already last year, so we better deliver those tools very soon. Well, we already, the Nara folks are already done postings. We just need to follow up and keep improving those tools and actually start using them for all our postings. Start quoting numbers based on stuff coming from your workload generator and start using Idlestat to actually produce numbers. I think the most important thing there is to get this energy model added into Idlestat so we can actually start producing energy scores. I think that would be a really valuable tool for postings. And for the rest, yeah, we need to add the utilization bits in the scheduler. We're working on that already. My song's already got patches on the list. We're going to post patches this week. CPU freq integration will be coming up soon. So yeah, we're pushing forward.
What is the general sense of from the schedulers, scheduler maintainers, about merging all of these changes into the scheduler?
I think there are definitely discussions to be had. I don't think they still understand all the details of all the changes that we're going to do, but at least I think they understand where we want to head right now. They have at least the overall picture of what I'm trying to achieve. So now it's going to be smaller discussions every time we will upstream a bit, but as long as we can relate to the overall picture and say this bit is going to fit in, I think we'll have an easier way of getting things upstream now.
Yeah, I think that was the most significant accomplishment of the workshop, which was that there was, in general, some level of buy-in to the idea, and certainly not an outright rejection of it. But I think there was definitely buy-in and some validation that this is, an acceptable path forward. So.
Yeah, I mean, I think the maintainers are happy to take it as long as you can disable everything.
Yes,
they're happy to move forward. It will take time to get it in, but at least we're getting there now.
Session.
Yeah, I think we're out of time. Yeah. When is the next session?
Yeah, it starts at 15 after.
Yes.
Okay. So it starts quarter past?
So it's a 10-minute break.
Okay. See you. Thanks.